The medians of two sets of integers, and these sets are given, they are equal. So which of the following is correct? Given that the medians of the two sets of integers that are provided are equal, we have to basically determine which of the following choices would be correct. And then there are 4 choices given. So there's a variable y in that set which is not specified. So the question is really around what potential value or set of values that y can take, given that the medians of these two sets are equal. And the options are y can have exactly one integer value, y can have exactly 2 integer values, y can have multiple integer values within a certain range, and then the option D is there is not enough information to determine the integer value or range of integer values of y. So this is a multiple choice question where only one option is correct and you have to pick the correct option. So we start by first of all noting that since these are sets of integers, the variable y, that has to be an integer, right? And then we basically start considering, case by case, what would happen, to the medians of these two sets as y takes on, different integer values. And that's the only way for us to be able to determine, what would be, the potential value or values for y. So we start with considering, 0, which is an integer. And first we consider the value of y square, because we know y square can be only positive, right? And it has only one value, because for a given value of y square, y can have actually potentially 2 values, except for the first one, because if y square is 0, then y can only take a value of 0, right? So the first case is simple, but as we consider more integer values of y square, we have to also consider both the positive and negative values of y. But that's coming later. So first, first tackle what happens when y square is 0. So for that, the first set becomes -6, -1, 0, 0, 1, 2, 4, 5, 6, 9. And remember that it's important that when we are considering the median, it's important to have the sets of values arranged in ascending order. This is very important for median. And once you do that in ascending order, so this is already in ascending order, it becomes easy to find the median, because then you look right at the middle value. In this case, there are 10 values in this particular set, right? 10 elements. And the middle value will be somewhere here. And we don't have to calculate yet what the median is, as long as we visually note where it is. And it's between 1 and 2. And usually when that's the case, especially when the number of elements is even, then we take the average of the 2 middle values of the median. So in this case, the median will be, the average of 1 and 2, which is 1.5. But we don't need to calculate that. This is just for us to be able to note where the median will be as we go through different cases. So this is for y square is equal to 0. And then the second set, we know that if y square is 0, the only possible value of y is 0. So the second case, again, we are arranging in ascending order, is basically this one. So where will be the middle value here? So this is already arranged in ascending order, so the median will basically, lie somewhere here. So this particular set has got, again, 8 elements. So since the number of elements is even, the median will be the average of the 2 middle values. In this case, 0 and 2, and the average of 0 and 2 is 1. So the medians clearly for this case are not equal. So they don't satisfy the criteria that's laid out, that the two sets of integers will have to be, or rather the medians of the two sets of the integers will have to be equal. So y equal to 0 is not an admissible value of y. What about if y squared is 1? So once again we lay out the first set. We take y squared equal to 1, and then you make sure it's in ascending order, and then it becomes super easy to find where the median is, because it will be right in the middle, which is here, between 1 and 2. So for this particular value of y squared, the median of the first set will be between 1 and 2, which is 1.5. And again, I'm not calculating the median value, because this is just for me to be able to note where the median lies, right? And for y squared equal to 1, y would have two potential integer values. So we start with -1, and for that the second set, we arrange that in ascending order. So when y is -1, the element minus 2y becomes 2, positive 2, right? So this is already arranged in ascending order, and again the median would be right in the middle. So the middle two values are equal here, so 2 and 2, so the median is going to be 2, right? So this is not equal to the median of the first set for y squared equal to 1, right? Now let's check what the median will be for y equal to 1 for the second set, because for the second set we know that y could have two potential values here. And for y equal to +1, -2y will be -2. So we again lay this out in ascending order, and we find that the median will in this case lie between 0 and 2. So it will be basically 1. So neither of these two median values of the second set for y equal to -1 and y equal to +1 match the median value for y squared equal to 1 for the first set, which was 1.5, right? So these are not admissible integer values for y. What about y squared equal to 4? So we are basically considering all the integer squares first, like so 0, 1, then 4. So for this value of y squared, if I arrange the first set of values in ascending order, this is what I get. And the median will be right here. So between 2 and 4, which is, the average of 2 and 4 is 3. So again, two sets of possible values of y for which y squared will be 4. So the first is y equal to -2. So for that value, the second set of integers when laid out in ascending order, so -2y becomes +4 for y equal to -2. And this is already in ascending order. So the median for this particular set is here, between 2 and 4, between the middle two values, 2 and 4 in this case. And now we note quickly that this matches the median for the first set, right, for this particular value of y. So what about y equal to 2? For y equal to 2, the second set of values, again laid out in ascending order, is as follows, right? And note that for y equal to 2, -2i becomes -4. So that's why we have like two -4s now in this particular set. And the median value is here between 0 and 2. So for y equal to 2, this does not match the median of the first set for y squared equal to 4. So the only two, or the only value of y for which so far we have found the median of the two sets matching is actually y equal to -2. So from here on, we consider what happens when y squared is 9 or greater than 9. Because then, as we arrange the first set in ascending order, y squared gets, placed at the one extreme, because on the extreme right side, because y squared is 9 or greater than 9, right? So the ascending order, y square will be always at the last. And the median in this case would be between 2 and 4, right? But what about the second set? Well, for the second set, if y squared is greater than or equal to 9, there are really two possibilities. So the first possibility is that y will be less than or equal to -3, right? And for that, -2y will be greater than or equal to 6. This is by simple inequalities. So we multiply both sides by -2. The inequality gets reversed, and we have basically -2y greater than or equal to 6. So for the second set, -2i will basically now lie at the extreme right side because it's greater than or equal to 6, and 6 is kind of the highest integer value we have, excluding -2i in the second set, right? So this is how the second set will look like if arranged in ascending order, and the median will be right here between 2 and 5. So the median won't be equal, right? What about for y greater than or equal to 3? So if y squared is greater than or equal to 9, so that's the other possibility. Y could be greater than or equal to 3. In that case, -2y will be less than or equal to -6, right? And now -2y in the second set will basically lie at the other extreme, right? Because it will be the lowest value in that set. And for this case, the median of the second set will be between 0 and 2. So not equal to the median of the first set. So we have basically now considered pretty much all the integer set of values that y can take. And the only value of y which seems to be satisfying the criteria that the medians of the two sets need to be equal is y is equal to -2. So the correct choice in this case will be option A. Y can have exactly one integer value.